Okay, let's go. Let's evaluate our model now. So in this sense, we're going to look at something. We're not just going to look at accuracy because accuracy doesn't take into account how many times the model got things wrong, which is important because what I use, which is a morbid example, say you're working with classifying skin cancer. So if the model gets it is 96% accurate, it looks great, but if it's gotten a lot of things wrong, how it's getting it wrong is very important because if it's saying someone doesn't have cancer when someone does have skin cancer, that is life threatening. So you need to look at parameters from the confusion matrix, which is the precision, the precision and recall essentially are the main thing because the F1 score is the average and support is the number of data points used. So let's go into so precision has to do with it's when it says we'll use skin when it looks at the model looks at classifying skin cancer, for example, it's gonna say positive. It says cancer, 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 and then sometimes it says it's cancer when it isn't cancer. So that's a false positive when it says that's cancer, but it's not cancer. So lower precision means you were saying that this model was saying something was cancer when it wasn't. And recall has to do with when it's saying it's cancer when it fails to determine its cancer and says it's not, it doesn't give the true positive, where it fails false negative where it says it's not cancer when it is. And now you can probably determine which one is better from in the in the cancer topic. When you're trying to classify skin cancer, you want it to be more precise. You if you seen it was really precise, you'd be happier with that. Although it will cause a lot of distress if you're saying someone has cancer but they don't. But it will lead to death if the model is predicting no cancer when there is cancer. So in that topic, you want it to be more precise than want a greater precise than recall value. So, for example, when we're dealing with a less morbid situation, our topic of discussion, which is the Setosa, this model is perfect at classifying Setosa. Precise. It never says it's always true positive. Doesn't say it's Setosa when it isn't. It doesn't say it's not Setosa when it is Setosa. And then this is the average between two, which is expected to be perfect because this is perfect. Now, as versicolor, we can see it's going to say it's versicolor, false positive when it's not sometimes. This is why we're still high, but this model is gonna do that. So it's something you look out for that if you see the model predicting vertically, you might be a bit okay. I'm pretty sure, but I don't know. Sometimes it does say it's vertical when it's not, but it never fails to determine versicolor. It always determines versicolor. It will say so. False negative is when it was versicolor, but it said it's not versicolor. So it's gonna catch versicolor, and Virginica is the opposite way around. So that's how this confusion matrix is working. I hope that's very clear. You can read the detail. Even sometimes when I'm working with the confusion matrix, I have to take a beat, think about it, then go back, and then it's fairly clear, and you can see the advantages of a precision using a precision matrix over just looking at the accuracy. All right. Like if this has been helpful, this process has been helpful for everybody, just like, subscribe. It wasn't easy to make. Thank you.